Hello students, hope you all are safe at your home. Today we will start with 11th mathematics topic, that is sets. Sets are defined as a collection of well-defined data or object is called set, or we can say a well-defined group of data is called set, or any group of data which is well defined is called set. Now, what is the meaning of well defined? Well defined means that if I ask anyone with a particular definition to collect some data, if that collection is unique, it means that is not vary from person to person. It means every person is making same collection, then that is called well defined. If the collection of data from person to person varies, it means every person is not making the same collection, then that will not be called set. Now for example, collection of vowels in English alphabet, that is A-E-I-O-U. If I ask anyone to make this collection, everyone will give me the same answer, that is A-E-I-O-U. It means this collection of data is a set. Collection of odd numbers, that is 1, 3, 5, 7 and so on. If again I ask anyone to make this collection, every person will be giving me the same answer, same result. So this is well defined collection, and this collection are called sets. Now let us consider another example. The collection of 5 most talented batsmen of India. Now, who will you take in the set? You will take in the group. It is more about your favorite ones. Maybe like I will say the Sachin and Virat Kohli is most talented. Someone will say, no ma'am, Mahendra Singh Dhoni and Sachin Tendulkar is the best. So, in this case, the collection will not same for every person. It means this collection cannot be said as set. So this is not set because we cannot measure talent. Again, collection of 5 best writer of India. It is not set because we cannot define who is the best. Here again the same problem occurs. We will take in the group to that writer whom we like the best. But again, every person will not make the same collection. That's why it is again not called set. Is it clear to you, students? If every person make the same collection, then that will be called set. And if every person is not making the same collection, then that is not a set. So what is the meaning of well defined? It means the definition of set must be clear that every person will got the same result. The result must not be vary from person to person. Now, thus the data collection vary person to person, then that will not well defined and such collection is not called set. The collection of data must not vary person to person. If the collection of data will be unique, if we ask to anyone, then that such kind of collection is called set. Now, always remember, if any of definition of collection of data is given to you, if that definition contain intelligence, talent, beauty, or dangerous. Such kind of words cannot be measured. That's why if any collection of data contain such kind of words, then that will never give you a set of data. Because for set of data, the definition must be well defined. Okay. Now some point to be noted. Every member of set is called element. Look at here. This is a set. This every single member, like first member is A, second member is E, third member is I, fourth member is O, and fifth member is U. All these members are called elements. It means we have 5 elements in this set. Set is always written in curly brackets. We have written here this sets in curly braces. Set are always denoted with capital letters like A, B, C, etc. Elements denoted as small letters like A, B, C, and etc. Let us consider example. A. If the set is given where we have 4 elements. Elements are A, B, C, and D. So I can say A is element of set A, or I can write it like this: A epsilon set A. It means we can read it like this: A belongs to set A. This epsilon symbol shows belongs. It means element A belongs to set A. Now, F is not an element of set A because we can see there are only 4 elements A, B, C, and D. It means F is not element of set A, so that we can write like that: F does not belongs to A. Simply strike out the epsilon symbol. It means F does not belongs to set A. How many number of elements in set A? 1, 2, 3, 4. It means number of element in set A. It shows number of element in set A are equal to 4. Again, taking second example, we have a set B. Here we have 5 elements. First is 1, -2, 5, 4, and 0. Number of elements in set B are 5. 1 is the element of B, or 1 belongs to B. -2 is element of B, or -2 belongs to B. We can read 5 belongs to B, 4 belongs to B, 0 belongs to B. All these 5 elements are belongs to B. But 2 does not belongs to B, 3 does not belongs to B. Is it clear? This symbol shows belongs. It means this element belongs to this set. And here this element does not belongs to this set. It means 2 is not a member of set B. Here -2 is member of set B. Now come to the representation of set. Sets can be represented in 2 ways. First, roster or tabular form. Second, set builder form. First, roster or tabular form. Definition: in roster form, elements are written in curly braces and repeated elements are dropped out. Point to be noted: repeated elements are dropped out. It means we will not write any repeated element in a set when we are writing a set in roster form. For example, first A, E, I, O, U. These 5 elements are written in curly braces. all the elements are written in curly braces. So that's why this form of set is called roster form or tabular form. Again, for second example, in the curly braces they are written 1, 2, 3, 4 and so on up to 50. It means all these 50 members are element of this set, and we have written all the elements in the set. That's why again this form is called roster or tabular form. It means in the roster or tabular form we always write each member in curly braces. So this is called roster or tabular form. Second is set builder form. In set builder form, an element X is written with a single common property for all elements. In a set builder form, we write only a single element X. And we also write a property which satisfies for all the elements of the given set. For example, A is equals to, that it is a set where element X such that this column is written, we can read as such that X is vowel in English alphabet. Here we have written only a single element and a property for all the elements, which is definitely satisfied by all the elements. So this form is called set builder form. We can also write like this, that is equals to A, E, I, O, U. When we are writing in this form, this is called roster form, and we are writing with a single element with a property, then that is called set builder form. Example second, B is a set where element X such that X is positive even number less than or equal to 50. It means B is a set where we have positive even numbers which are less than or equal to 50. We can also write like this, 2, 4, 6 up to 50, because less than and equal to, we have less than and equal to, that's why we also consider 50. If we are writing all the elements, then that is called roster form. And if we are writing only a single element X and the property for all elements, then this is called set builder form. Or we can say that the set builder form is a definition form where we are writing a single element X and we are defining what is X. Now taking another example, write set of natural number less than 10 in set builder form. We are to write natural number less than 10 in set builder form. In set builder form, we need to write only a single element X. So I am writing A is equals to a set where X belongs such that X is natural number. Since our definition is saying that X is natural number less than 10. We can also write in roster form like this, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Because we are to take natural number less than 10. So we will include 9, we will not include 10. This form is called set builder form and this form is called roster form. Taking another example, write the set of days of week start with M in the roster form. we are to write in roster form. So what is the definition of roster form? We are to write each and every element. We are taking a set A. In set A, we have only one element because the only one day is there which start with M. And again, when we have any set which contain only one single element, then that is also called singleton set. This is called singleton set. Example third. Represent the set. We are given the set where the elements are 1, 2, 4, 16, 25 up to 100 in set builder form. Set builder form, it means the definition form, or in a single element X. In the form of single element X, we can write that 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4, 25 is the square of 5, and 100 is the square of 10. Here we got relation between these elements. So what we can write? A set A where is element X. That is fixed. We have to take element X. Now element X is such that X is equals to n square. What is X? X is equals to n square. This is our n. 1, 2, 3, 4, 5 and up to 10. And what is this n? This n belongs to n. It means n is natural number. We can also write n is natural number. And n is greater than equal to 1, less than equal to 10. Taking another example, represent the given set in roster form. We are given in set builder form and we have to write the roster form. What is the definition? There is element X. X belongs to n. X belongs to n means X is a natural number and X square is less than 5. Let us talk about natural numbers 1, 2, 3, 4, 5, 6 and so on. Taking the square of it because we are to compare X square. We are not to compare X. We are to write element X in A, but we are to check condition for X square. So take X squares. These are our X. What will be X square? X square will be 1, 4, 9, 16, 25, 36 and so on. Now X square is less than 25. So we can take X square only 1, 4, 9, 16. We cannot take 25 because we need less than 25, not equal to 25. Now it is our required data. Now what we are to write in the set? We are to write element X. And what is X? X is 1, 2, 3 and 4. If suppose I am to write set B such that X plus 1 and X belongs to n, X square is less than equal to 25. For simplification, I am just taking less than 25. So we can compare this question only. It means the same condition we have. We have taken X, X square and so on. But in this condition, check what we are to write. What are our element? Our element is X plus 1. Here our element are X. So we have write directly only X. But in this case, we need to write X plus 1. So what is X plus 1? 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4 and 4 plus 1, 5. When I have changed slightly the definition, the set is also got changed. Remember the thing, what are our elements? Our element could be written as x plus 1. If we are taking x square as an element, so then that in that condition, our element will be 1, 4, 9 and 16 in this particular question. Okay? Now come to the type of sets. Empty set or null set. Any set which does not contain any element is called null set. It means any set which does not have any element. It means that is null. It does not contain any single element. It does not have any element. Then it is called empty set because that is empty. Or we can say null set. It is denoted with this symbol that is called phi. Let us consider an example. A set of odd number which are divisible by 2. A set of odd number which are divisible by 2. It means they will not have any element because we know that there is no such odd number which are divisible by. In this case, we will not have any element in set A. Students, just remember this thing. This definition is very clear. If I give anyone to collect this kind of data, everyone will give me the same result, that A is not having any element. It means this collection of data does not vary from person to person. So it is well defined. It means it is a set. Although it is a set, but it does not have any single element. So we can denote it as phi. And how many number of element in set A? 0, because it does not have any element. Let us consider second example. A set of name of the day start with J. Name of the day start with J. We know that there is no such day. Name of the day. So again we don't have anything to write in B. So it is also a null set or empty set. Can be denoted with phi. Again it is a set because it is well defined. Every single student will give me the same answer for this question. And B, it means number of element in B are again 0 because it does not have any element. Suppose I am given a set C such that, look at here, there is a set C which have an element phi. It is having an element phi. It means it is not empty. It means it is not phi. It means this set C itself is not a empty set. It have an element. And how many number of elements C? That is 1. That is phi. Now, come to the next topic. Finite and infinite sets. If any set which contain a finite number of elements is called finite set, or if any set which contain infinite number of elements will be called infinite set. Simply, if an set have finite number of elements, will be called finite set. If a set have infinite number of elements, it will be called infinite set. Example first, a set of even number less than 10. And the result will be A is equals to 2, 4, 6 and 8. How many number of elements are here? Number of element in A, 1, 2, 3 and 4. 4. 4 is a finite number. It means set A is called finite set. Second example, a set of odd numbers B. B is having elements 1, 3, 5, 7 and so on. How many number of elements are there? Number of elements in B is infinite. We don't know how many number of elements are there. We cannot be count them. They are infinite number of elements. So the set B is called infinite set. Let us consider a set C such like 1, 2, 3 up to 1 lakh. Up to 1 lakh. It means C is having how many number of elements? 1, 2, 3 up to 1 lakh. Number of elements in C are 1 lakh. It means a finite number. Hence, set C is a finite set. It is not an infinite set. The number of elements could be in lakhs, in crores, in millions, billions. But they are countable. So if the number of elements are countable, it means that is a finite set. If number of elements are not countable, such like this condition, then that is called infinite set. Okay, students? Next is equal sets. Two sets A and B are called equal set if both have exactly same elements, otherwise called unequal. Exactly same. It means set A and B will be the same. Whichever element are there in A, they will be also in B. And whichever element in B, they will also in A. Then two sets will be called equal sets. For example, we are given A as 1, 3, 5 and B is having 1, 3, 5, 5, 3. Just remember that we will never write the repeated element in a set. So we can drop the repeated elements. Then what we will have in B? We are having 5, 1, 3. Here order does not matter in sets. We can write in any arbitrary order. But we are not to write repeated element. Repeated element must be dropped out. Now check. A is having 1, 3 and 5. B is also having 1, 3 and 5. That's why A and B has exactly same elements. So A is equals to B, or we can say A and B are called equal sets. Taking another example, A is having 1, 3 and 5. B is having 1, 3 and 2. Here in both the cases, both the sets, A is having 1 and 3, B is also having 1 and 3. But when B is having 2, B is element of 2 is element of B, but 2 is not element of A. And 5 is element of A, but 5 is not element of B. It means this both are not exactly same, because every element of A does not belongs to B and every element of B does not belongs to A. So that's why A and B are not equal set. I can write A is not equal to B. Considering the third example, are the following pair equal? A is having element X. X is letter in the word follow. B is having element X. X is letter in word wolf. First we will write in roster form so that we can compare. A is equals to FOLW. Why we are writing it like this? First element F I have taken. Second is O I have taken. L. It is written 2 times, well, but we will take only 1 time. because we do not write repeated elements. O is already we have taken, so I will not write it again, and W. These are the elements of A. In B, I have first element W, second element O, third element L, and fourth element F. Now check. A and B are exactly same. All the element of A is also element of B, and all the element of B also element of A. So A is equals to B. It means A and B are equal sets. Thank you, students. I hope you will find it helpful for you. Now I am giving you a worksheet, and you are to also solve exercise 1.1 and 1.2 from your book. Thank you.